Oh. I forgot to change the titles. This is not John Park's workshop. That's what I get for rushing. It'll be right on YouTube. Hello everyone, this is an early edition of Deep Dive. We'll get going in just a second here after I pause my YouTube streams. I rushed through my checklist and didn't do it. So hopefully on Twitch, I updated the title. Should be right on YouTube. How's everyone doing? I hope I caught enough folks with the Deep Dive Discord ping. But it's also exciting. It's kind of fun. So let me start from scratch. My name is Scott. I go by TanNewt online. Let me mute my desktop. And this is a deep dive. So I deep dive on CircuitPython and generally CircuitPython work that I'm doing. And that widget's still broken. So I work for Adafruit. Adafruit is an open source hardware and software company based out of New York City. I work remotely here in Seattle. And I do these deep dives normally at 2 p.m. Pacific, but I just scheduled a late breaking doctor's appointment for my 2-year-old. He's got a bit of an ear infection and they wanted to take a look at it. So here I am, running early. It's like, I got time now, I might as well do it now. And it should be good for European folks, so say hi in the chats. This is hello Manfred and Shravan from India on LinkedIn. Glad you could make it. That's the exciting thing about trying a different time is that some other folks can come, which is great. So my name is Scott. We talk about deep dives. If you have questions for me, feel free to drop them in the chats. I love to answer questions that people have. Normally I work on CircuitPython. CircuitPython is a version of Python designed for little tiny computers called microcontrollers. Here is an example. Underneath this is a little tiny chip. Hi, Brad. Siobhan. Pretty good, a little busy. But little tiny microcontroller that has Wi-Fi. Plug it in, it shows up as a CircuitPy drive, and it has Python code on it that you just edit with a text editor. So that's how CircuitPython works. I was thinking today we wouldn't actually do much CircuitPython. Hi, XMicron. I'm glad you can make it. I want to work on the Stema G0 stuff. I think I was doing some board layout stuff that I thought about doing too, but I'm kind of beaten down by BGA routing. So I figured I'd go back into my safety software land a little bit. But like I said earlier, I'm happy to answer questions as well. So if you have questions about CircuitPython or embedded stuff, I'm happy to try to answer them. I make no promises, but this is usually a pretty chill stream. Usually we go about 2 hours. I think today, hello Fede2, glad you can make it. We'll go until I get hungry for lunch because doing it before lunch. I usually do it after lunch. So yeah, we'll see how it goes. The Stema G0 stuff is something that I felt like if I just had a block of time, I'd be able to like move the ball forward and get it working. So I just realized I forgot to grab the hardware out of my backpack, but I can do that too. Any questions before we start on that? I also did some more build stuff and I'm just like, I don't like this build stuff. And I switched the Stema G0 stuff over to the new Python build stuff. So I'm kind of excited to poke at that some more as well. Hope everyone's having a good day. While I'm waiting for questions, I know the YouTube delay is usually pretty bad. I'm gonna just get the hardware out of my bag here. Oh, I zapped it. I still have a static electricity problem. Um, oh, great. We got some questions here, so let's answer those. Tyeth says, is there anything left on BLE land that you still wish for, but not now? FedA2 also says, I missed more than a couple streams and CircuitPython meetings. What's the progress of Bluetooth on the new ESPs? Yeah, so yesterday I did a review for Dan. I think it's merged in. Actually, I haven't even gone through my email. I literally like got in and I would like scheduled so I have a 2-year-old Ari, and he had some like drainage from his ear and he's had his eardrum burst. So I called the pediatricians and said like, hey, should we worry about this? Do you want to see him? And they're like, we should see him. So that's why I got a last minute doctor's appointment for him this afternoon. So we're going to get him checked out later. And so yeah, I haven't even got through my email. I just like literally got to my desk and was like, I can do it now. And I have a streaming checklist of all the things I have to do before I start streaming. And so I got through that, and here we are. Got myself some water, used the bathroom, that sort of thing. Yep. Yeah, Tyeth did some testing originally on the BLE work I did, and Dan's pull request was merged in and fixed up a bunch of stuff. Various Espresso BLE fixes was merged in, so the Nightly should have pretty solid BLE support on ESP now. And thanks to Dan for doing that. I've been kind of out off and on for the last couple weeks, so thanks to FoamyGuy for filling in. FoamyGuy will be filling in next week as well because I'm taking Friday off for the long weekend here in the US for July 4th. So FoamyGuy offered to do next week, which was kind of why I was like, I don't want to, like, FoamyGuy would probably fill in today later for me, but I was like, I'd rather do it and just do it early. Because I like doing deep dives. So yeah, BLEs should be in pretty good state. I kind of got burned out on it anyway, honestly. It's like kind of tricky to test, and that's a little bit of my hesitancy for doing the Stema G0 stuff, because it's going to be a dual device sort of setup for testing. But if anybody has experience laying out BGAs, so the other project that I have is that I'm really keen on making Adafruit boards with the i.MX 1060 on it, which is the higher end i.MX that has a meg of SRAM, which will be great for CircuitPython. So I was like, oh, I could lay this out, and I got in the weeds of like BGA layout because those higher end ones are only in BGA. So if you have experience with like hardware layout for BGA stuff, the main question that I haven't been able to figure out is how do you, the data sheet for the 1060 doesn't tell you doesn't give you a model footprint. And so how do you figure out, given how many pins on the BGA? It's 196. So I have all these files open already. Here's the data sheet. Let me switch to the desktop. Have quite a massive DSP. Interesting. I didn't realize that. So this comes in a 196 pin 10 by 10 0.65 millimeter pitch, or a 12 by 12 0.08 millimeter pitch. And it has this like nice diagram. Hi, Timon. You probably can answer this. I think you've done some BGA stuff. But I was trying to do a feather design with the i.MX 1060 on it, and wanting to then just like plop it into a Metro and a Grand Central, because I think it's good. It would be an awesome CircuitPython board. We just like got to get over this hurdle of BGA. 0.8 pitch is the best. Yeah, so I was running numbers yesterday, and that's what the paper is in my backpack. Sorry. I was doing it at the makerspace yesterday. Okay. So I was trying to figure out, I did look like, you need to write some Python code to create a library for it. Xmicron says you'll need a 6-layer board. Okay, so let's talk BGA because maybe you can help get me over the hurdle, and maybe I could work on it. So I want to use JLC, and so I was trying to figure out how to fit within the specs of JLC for it. So I had this diagram. This one is trying to figure out the constraints for being able to place a via between. So these are meant to be the BGA pads. And then I was trying to figure out the constraints for being able to put a via between all of the pads, even if they're different nets. And I came to the conclusion, I think, which Xmicron is, well, one of the conclusions Xmicron is saying is like, I have to do the 0.8 pitch, which is this one. I also have a diagram for this one. But you'll see that I was like trying to subtract some numbers to figure out my tolerances. My main question, one question I had was, given this diagram in the data sheet, how do I figure out what diameter the pads need to be for the BGA? Yeah, Timon says, will fit easily into JLC's constraints, but you want to use their advanced service. A 0.2 via and a 0.8 pitch. Oh, a 0.2? So, you have to pay for the more expensive holes, right? Let's pull up JLC. So if I have the dimensions of a feather here, 23 by 51. The eye tracking is too good. So 23 by 51. And I was hoping to do it as a 4-layer. You want via in pad. So this is why I was coming to the question of how big can my pads be. Via in pad is free on 6-layer, but 6-layer is more expensive than 4-layer. Even with, so I ran the numbers yesterday. 4-layer with 15.15 millimeter vias is $112 for 200 boards, and 6-layer is $170 for 2. And if the pads, right now I have the pads as the smallest, the 0.25. The pads themselves are 0.25. If they need to be 0.25, you would still need to pay for the finer drills. If I could make the pads bigger, then I can use bigger drills on the 6-layer. And then maybe that's cheaper. This is what I was just getting hung up on. So if I'm doing a feather size board, and let me just close this so we can see the price. It says $2 now, but if I pay for the fancy drills, then it's $50, $52. That's for 5. That's insane. Look at this. If I make this 100 or 200, it doubles the price, even though I have what, a ton more, a ton more. So that is $106 for 200. I just pay for via and pad and the 15 millimeter drill. That's not a price point I would get hung up on. I do JLC a 48-pin BGA 08 with a 4-layer with 0.25 via between the pins. Yeah, well, one other thing that I was getting at, well, I was also looking at what 1060s they have in stock. This is the other thing I like to look at, is just like prices for JLC assembly. So if we look at what they have in stock, they've only got, so the VL and the VJ are which package it is. And we can see that all these all the VLs are the 0.65. You pay mostly for setup costs there. Mass production price is a different matter. Yeah. So ideally, I'd do the 0.65 10 by 10 on JLC but I had to pay for the... Oh yeah, you know what? The problem is I've been doing this on my laptop. You can't do 196 pin with a 4-layer board, only if you omit some pins. Yes, I'm not planning on using all the pins. So in terms of pin out, the things I'm thinking of are feather. In particular, I was hoping to fit on the USB host feather. So because the 1060 has dual native USB. And then Grand Central and it is the most pins I want to get out, and I don't actually know what that count is. So Timon's just saying, just like, don't worry about the drills, just pay for the pricey drills. BGA fan out at teardown. So what I was trying to do yesterday was starting to lay out, and maybe I should I could commit it and push it and then try to pull it up. I was trying to do the decoupling caps in the middle of the chip to start. All right, so folks think that's possible. It's like pretty warm in here. Let me put the fan up. If I want to stream for a while, I gotta... Yeah, DCD says, are the teardown videos up? I don't know. I just looked at my Pi Cascades talk is not up either. Yeah, that feels nice. Would you do 4-layer via InPad, Timon? Does that buy you anything? Because I think that's what this is. It's still slightly cheaper than the 6-layer. Makes your life a lot easier. Yeah, it certainly would. Because then you can just go straight down. Yeah, if you want a penny pinch, you can do it without, but it's much more annoying. It's certainly not going to be a cheap feather, right? Like the 1060 is more like, it's going to be on the higher end side. Although the Teensy's got the same chip and it's not that much. Do folks want to work on this hardware stuff, or should we switch to software, the Stema G0 stuff? Talk slides are up. Oh, Greg. I like Greg. Greg is great. Save that. What do folks think we should do today? Are there other questions? Sorry, I'm on my laptop and I've been working on it at home. Stick with the hardware? Okay. I'm gonna try to push, where did that go? Sorry, I'm going to try to get my KiCad files over, because I usually work on this at home during the night, so that's why it's on my laptop, not my desktop. And I was kind of like so like disheartened about it that I thought that I'd where did it end up? Oh, okay. And then you'll be able to follow along. I have a Git repo already. Oh, maybe I pushed it already. All right. Oh, I don't need this backups directory. I did push it already, so I know this is not good YouTube, but I'm also not known for good YouTube. I'm known for backups. Sorry, I don't want to push all the backup files. How do I unstage? Restore. So it looks like there's a... Yeah, that looks better. Just cleaning up my commit. I was a little bit cavalier with what I added it to. Okay, good. All right, updates. All right. All right, it's pushed. All right, sorry. I know the top of my head is not pretty. Do you have a question? Not that I disagree, but why do you think the i.MX 10 chips would be nice CircuitPython boards? Yeah, the laptop is Linux. It's Arch Linux. It's set up pretty much the same as my desktop. It's a framework. If you haven't looked at framework laptops, I recommend them. And it's pretty cool. Look, I have a blank keyboard. It works pretty well most of the time. The speakers are terrible. That's my main constraint. The webcam's not great, but they actually just announced that they're doing a new webcam module. One thing that they like to point out is that frameworks have these, sorry, let me turn off eye tracking. They have these little slots, so you press the button and can pop out the slots. Internally, there's USB-C, but you can have it, like the adapter kind of built in instead. Yeah, this is the 13. The 16 looked a bit, I don't do any module swaps. It's more about like just, I have a C here, an HDMI, a C here, but I also have USB-A, which I didn't before on my Mac. And then this is actually a headphone jack too. Although I use Bluetooth headphones just fine with it. So I'm a fan. I have the AMD main board, and I'm excited for another main board to come up. All right, we'll look at Greg's talk in a second. I'm gonna have to change the name if we don't get to the Stema G0 stuff, but that's okay. What did I call it? Feather 1060. So if you want to follow along, oh, I guess it's private. I can make it public if folks want to see it, but I was just using it for synchronizing. All right, I think I have kicad, and I have a Feather C6 open. So let me just open. All right, so here's the project. That's true. The RISC-Vs are tiny in comparison to, say, a Pi 4. So Fede2 asked, like, what's neat about the 1060? It's a ton of RAM, it's quick, and it's got dual USB, are all sort of things that catch my eye. I've been known to spend a lot of time looking at this page, the i.MX RT page. It's a great summary of all of the different ones. SamacSys instead of making your own footprints. I did make my own footprints, but I used the BGA generator in KiCad. I have not heard of SamacSys though. The 16 seemed pretty bulky to me. I like that I can throw it in my laptop or in my backpack and not have to worry too much. Although I could use the grunt of the GPU or something, especially because I was looking at the large language model things. So right now we have the Metro M7, which is this 1010. It's actually a 1011. So it's 500 megahertz, LQFP, low cost, but it only has 128K SRAM, and because we're going for speed, we use half of that. You can allocate 32K chunks to be tightly coupled memory that run at the speed of the CPU. The rest of the memory runs at a quarter of the rate. So when I was shooting to make it really fast, I took 64K away from that. So it's really limited, really RAM limited. And so what's interesting to me is the 1060, and this is the same as the it's the same as the Teensy 4.0 and the 4.1. There's a KiCad plugin too. Let me just SamacSys. I think I might have product services footprints. Can I just search for it? Yeah, I think I did end up here. Oh. Here we go. CVJ DVL download model. Oh yeah, I did end up here. Yeah, I didn't register. I did my own symbol too. Symbol included. Oh, they did just one giant one. I took some data that I knew from them and I did it. I can show you. I think I'm over this hurdle. Although, again, I don't know how they figured out. I wanted to see what their pad size was, but okay, so let's open KiCad. So you see I literally took the Feather RP2040 and just modified it. And one thing I did was, here's the regular Feather stuff, and then like kind of below the fold is where you put the new things. And I made a footprint just for the 1060 to like encompass all of the decoupling caps and stuff. Remember, I'm not a hardware person. If you don't like my schematic, sorry. But power control and then all of the boot, or all of this. Simply, you probably want to change. It's more about getting correct footprints that are hooked up correctly. Well, I mean, it's just auto-generated. And I actually these bits I auto-generate. The mapping between the name and the ball number was all also auto-generated. You can download, if you have an account from NXP, you could download information from them about like how things are connected. So I wrote a little quick Python script that just generates the symbol for me. And then the footprint was just a generated from kicad thing. But yeah, it's worth double checking at least. So here's the design. And I turned a lot of stuff off, like labels and things. But this is the 0.65 version. And I was just trying to start getting these ones here. But I don't think the math works out. I don't think I can do, I guess I could do 0.6. I could do 0.65 if I did, via InPad, I could do 0.65, I think. So maybe that's the best option. So let's do that. Although even then, like putting these are 0402 decoupling caps. You're looking for recommendations from landing pad. You usually get that in separate app notes from the particular package from the vendor. I found like an app note for the particular package, and it had the same pages that the datasheet has. It still doesn't have like the landing pattern on it. Anyway. Okay, so I also compiled a version of KiCad that can open their reference EVK files. Just to be able to see it in KiCad. Again, I'm starting to feel overwhelmed. Do I really want to do this? But yeah, if I do V and pad, then I don't have to. Then I can go straight down. They're far enough apart, and it wasn't that much more. It added. Via covering is $17. Just not that much. Okay. So I'm going to delete these vias. I did, so if you're used to the colors being different for the front and the back of the board, I was really wanting a visual on which balls of the device I was going to need to use. So I've used this net coloring to demonstrate what the balls are for what. So yeah, that's where I'm at. So I can change, if I'm going to pay for it and not worry about it, then I can go predefined sizes. This 0.15 and 0.25 are the smallest. Constraints. Teardrops, net classes, via size. So for all these net classes, I'm going to want the smallest ones. I'm so out of my element when it comes to hardware stuff, and this would be the first BGA that I've done. Size is a tenth more. I'm a little hesitant to switch to the 6 layer because it's like on promotion right now. Who knows like what the cost will change. Like the 4 layer is more mature, and so like I trust that cost to stay the same more. Is using a 0.29 millimeter pad diameter. Okay. Okay. All right, so what we can do is we can say cancel, open in footprint editor, and it opens the footprint, and we can say edit diameter 0.29. Okay, and then what we could do is we could say push pad property just to other pads. And now they're all the same. And then you say, let's load. Main issues through V is not the amount of signals you need to run. All right, so now all my pads are slightly larger. So this kind of pattern here is the way that the EVK lays out these decoupling capacitors. But I was looking at the teensy, and it's got them all kind of like in the same rows. I don't know. Is that where you would start? The other things to think about are these green ones are the USB, and then all these components, this is the flash, and then these are the 2 crystals. And I think it would need to be routed kind of like these are the crystal inputs here, and then these are flash inputs to here. I was thinking I'd start in the center with these decoupling caps. I'm not worried about like all of the pins to the feather footprint, although I did mark the TX and RX over here. Maybe I was thinking about turning it 90 degrees. That's why I haven't really started routing. All this stuff would then go here, although there's 2 buttons. Like your boot button and your reset button are over here. But I was thinking about turning it 90 degrees. That would make TX and RX always start with power layout. Okay, but to start layout, you got to decide like what orientation you're going to put the chip. This is all the USB host support circuitry. We can view the 3D viewer here. Gives you a little bit of an idea of what we're going for. So there's like space here if we want it. Like maybe that's where we want to put the crystals, and then we could put the flash here on this corner. Putting the layout and the traces down as routing, yeah. So I'm kind of thinking maybe I do want to do a rotation and put the crystals here. The problem is that like the USB traces, the USB I guess could go this way. And that's probably for the better actually, because right now USB's right here. I think what we could do is we could just say all this stuff. I don't remember what this is. That's probably a regulator. And this stuff's on the back. But we could just do rotates counterclockwise. Okay. And then this stuff is going to go. Oh, that's not what I want. I've been doing this on my laptop, so doing it on my desktop is a little bit of a switch. But we could probably actually go like here. But one USB close and one USB far away. Let me turn off back footprints. There we go. That makes it simpler. So here's one crystal. And I think that one's probably the faster one. I don't know what this is. This is a resistor. That is not going to matter. So this crystal is going to go here. And then the RTC crystal go this way. I don't know what that is. That could go there. And then this is the flash. Flash can go there. I followed and enjoyed Esden and their layout work for the Glasgow Internet Explorer used back. Great experience. Nice. Awesome. What do we think? Is that gonna do it for us? No, the flash is not gonna work. What we could do is this is the stemma port. It's like a vertical stemma port. But we could move that to this side. It doesn't need to stay where it is. We could butt it kind of up against where the thing is going to be, and then move this. So it's okay if it's down. Come on. That's what I want. I don't have a PMIC. I do have like whatever regulator I started with. I didn't see a PMIC in the design. It just has like a delay, an RC delay circuit. Yeah, that looks more reasonable. Although flash could be... Actually, if it was over here, that would make it somewhat simpler. I'm like looking at the rat's nest here. Probably put that more towards the corner where you have the flash, given the power input constraints there. Yeah, so it will be a double-sided board, so I was thinking I would just put it on the other side. So if I turn the back footprints on, there's a lot that I've just like thrown over on the back. Maybe what I need to do is just take all these capacitors and move them. Like start with the big stuff. And then work my way out. I could show you what I have in the schematic for power sequencing. So lots and lots of decoupling caps, probably more than I need. It has an onboard regulator, so there's a inductor that the low power comes out and then it goes back in to this VDD sock in stuff. But there's this power switch input. So you delay filling this capacitor. So you have the resistor into a capacitor to delay turning on the DC to DC converter internally. And then externally, I have just the regular 3.3 volt regulator that is kind of like standard for feathers. But yeah, I mean, that makes sense to try to put there. I'm a little worried. Well, I don't do hardware layout. This is the charging chip. Actually, we could even turn the front footprints off. So my thinking was to put most of the stuff on the back. DCDC circuit first. You might want to be tight. Okay. So I was thinking the regulator would be on the back. That was my plan, is to move it to the back. And then that leaves room for the crystals. This is a button, so we don't want to be too close to that. But then again, buttons are not high-speed signals, which is kind of nice. My grid is probably not great. And then DC to DC stuff is over here now, I think. Oh, you know what? That's how I do middle click. So this is the delay. And then DC to DC in. So there's 3 DC to DCs in. And the footprint on the back. Oh, there's this here. So the nice thing is that we could put, like, I think there's some pretty big decoupling caps. Although we could still put them on the back side. So DC to DC switch. Here's a VIA we don't need. I like the unroute selected. So we have plenty of space to put decoupling caps for the DC to DC switch on the back side. This is a big inductor. So one of the things that's weird about this is it actually, because it can be battery powered, it actually has a boost converter to boost the battery voltage back up to 5 volts for the USB to host. Oh, hold on, I've got a phone call. Let me mute and then I'll pick it up. It's my wife. All right, sorry about that. She didn't know I was streaming because I'm not usually streaming at this time. So I'm gonna call her back after we're done. Okay, so let's see. What else? Yeah, she just texted me saying, oh, I thought we'd do it after. Sorry. Coordinating. Coordinating. She's gonna go get him, I guess, and do nap at home. Which will help too. Okay, so I did pins. This is decoupling for the PLL. Decoupling. Lots of decoupling. USB. And then this is the regulator on the backside. I don't know, I guess we could just start doing it. So I guess if I can just go straight like that. If I do via and pad, like Timon's saying, I can, let's see. Okay, so DC to DC in has a 22, a bunch of 220s, 31, 30, and 29. So I'm looking for 25 and then 29 through 32. And we're going to want to put them all over there. Here is 29. So maybe we put that there. And this is the delay resistor. And it goes here. Wow, that doesn't fit very nicely. So the outline's telling us where it is. DC, DC in. DC, DC in is actually 3.3 volts. Balls are often laid out so you can just place the decoupling pads across from the back. Okay, cool. So DC, DC in should be 3 volts as well. It's just not marked that way, or I haven't actually connected it. That would be true. Okay, so let's duplicate that and attach that. And save, tools, update PCB. There we go. So this is a resistor. It's probably not that important to get. So I don't care too much to use all of the things, all of the pads, so it's really not that big of a deal if I have things in the way. Although L2 is gonna want, so this is the, 35. Maybe what I'll do is I'm going to open this. So I tried to split them off so that they're all separate. So I'm gonna have the schematic open off screen just so I can see. Although there's not a lot off screen. Close this, make it smaller, make it smaller, it'll center it. So do double check if you can omit connections. It's not always the case. They're internally connected. Rely on a connection on the PCB side. Yeah, I mean, the odds of me getting this right the first time are pretty slim. But I think it'd be a cool board. It would be the quickest and the most RAM. Can I? Oh, it's so tight. I have a little more room than what you can see. I wonder how, I'll have to watch a bit of the stream from Esden about how he's set it up. Okay, so this one, C35 is SD1, which is not quite visible. SD1 is K5. K5 being right here. This is the big one. So maybe we want to be a little bit over that way. And then, can I click? Yeah, C36. Problem is, not all these are as critical as some of the other ones. Which I think is what Simone was getting at too. Like, oh, come on. That wasn't R? Twitch stream for your convenience. Thank you. What I really want is these DC to DC ones. So C32 is there, 31, and this one is 30. So both these we want over there. Because we want to worry about DC to DC inputs first. Sometimes it selects the middle, which is not what I want, and sometimes it selects. Sorry. I don't know. I don't know what the right way to do this is. I have a grid that's not helping me. This one goes with K5. Okay, so it doesn't actually matter. I don't know. C25. This one definitely needs to be. So that's like a bulk, bigger decoupling cap, and we do want that to be close. Yeah, it's right next to the 420, and then there's 1, 2, 3. That'll work. I'll scooch those around a little bit. And then that's for DCDC in. Then there's a lot of these VDD sock ins. And they're on this 1.1. I don't know what I'm doing. Okay. So now let's do, these 0402s do not fit that well. Oh, that's the 4.7. I can go a little bit further away. In fact, oh, that's not the right button. What am I doing? This is the downside of not having labels on your keys. You can't see what buttons you're pressing. That's a 220. Grid is all screwed up. Oh, and the grids don't apply? Darn. I had a better grid on my laptop. Okay, so these are all, those are all the input decoupling caps. It's a lot. O201. What can I do O201 on JLCPCB assembly? Can I go that crazy? I mean, even the data sheet says to use 0402s, which I'm kind of surprised by. And in the EVK, they only have like 4 or 6 caps directly under the board. I'm not sure it has as many caps as they say that you should have. We're gonna do standard because it's double-sided. Minimum package 0201. Is that insane? Is it insane to do 0201s? You can definitely fit this with 0402s. I mean, I'm not going to hand assemble it. I already know that. And they say in the datasheet that you should be able to do it. The number of caps is quite a lot. Depends on who you ask. Yeah, I could talk a little more about it too. She would have an idea. 01005. I don't even know what that must be smaller than 0201. That's, I guess, half the size of 0201. That's pretty wild. How well does an 0201 fit? Does it fit right across these balls? I'd be tempted. Capacitor 0201. Don't tell me they have a hand, oh, they have a hand solder 0201. That's insane. Oh, would it? Cancel. I think it would. My grid's not helping me. I think it would span just fine, right? Why isn't it snapping right? Hold on. Edit grids. New grid. BGA by 2, and it's 0.0325. Oh, look at that. Can you do 2 of them? Can you literally put them next to each other? It doesn't think you should. Yeah, I think Lamore would favor ones. So that it's telling me I wouldn't be able to, like the standard footprint would want more space than to just put it directly over the balls, even though it's spaced right. That is very tempting. Like, it kind of looks like that's what it's designed for, really. Right? Like, it's designed to be able to... Where's my delete? I would ignore the courtyard. Oh yeah, daycare is having a goodbye picnic. Oh dear. Design rule checker. I haven't even tried to run that yet. Datasheet recommends 0402s. They don't do a great job. So there is a 1060 hardware design guide. Oh, that's the search for it. And they tell you, so this is what I was reading for like the number of caps. So here it says like minimum quantity decoupling caps per power rail. So that's what I tried to encapsulate in all of the schematic. I think this is Ari's last day at his current daycare because he's moving next week, and they were gonna have a goodbye picnic for him. They could do it for lunch instead, but I think it's at 3 o'clock, which is when his doctor's appointment is as well. Yeah, so here it says like for these use the 0402s, and then for the 22s use 0603. So that's what I followed. How you place all those, I don't really know. I think let me see if I can't find the schematic of the actual EVK, because I wonder if I have more than what they actually used. I do feel like if I figure this out, then it's gonna be like all of this like support circuitry stuff should just be able to like copy and paste from one design to another, especially because I'm starting with the small one, which is probably stupid, but then I could do a Metro and a Grand Central pretty easily. 1060 EVK design files. Let's just take a look at that. Schematic. Okay, so here's how they did it. Let's zoom out. They love to add so there's some decoupling caps. I do kind of like this process of like how they have power rails for GPIO. So I hit decoupling caps there. GPIO decoupling caps, which I think I have. OTG, backlights, PDD. Okay, so here's the DCD to DC circuit. So DC to DC in has 1, 2, 3, 4, 5. Those are the ones that I have. And they're almost the same number, which is funny. And then for the output, they have a 33 UF and a 0.22, which I'm not sure if I did that or not. And then VDD sock in. Where do they have that? Ah, so that's then up here. Maybe they do have all these caps. Oh, this 22 is marked as do not place. Oh, that's a no, that's the 22. I think I do have that in my design. But they do have the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and a 4.7. So they do have a ton, just like I have a ton. Actually, they have more than I do. Because I only have 5. They have 9. Oh, I don't know. I don't know, folks. I think I may just call it. Call it and deal with child stuff. If you want to work on this, they show layout, but it's in a zip file, and it's an Allegro file, which I could, yeah. It's not linked up, so I wouldn't be able to just click around. It's kind of hard to figure out where it all is. I'm surprised it has all 9 though. You know what I could do? Let me just find my EVK. We could just look at it. Because I think they label all the caps too. Let me pull it out. My initial reaction is, oh, they didn't use 0402s. Like, maybe they did. They definitely used some. Okay, so let me show you what I'm looking at. You know what we could do? Let's switch the hover cam on. Let's take a real good look at this. Hopefully OBS and Linux will be happy when I plug it in, but we'll see. I do find hardware fun, but this is like at the limits of my fun. What I consider fun. Okay. Let's see if we can get that going. So it is a VL. So it is the smaller chip. Can kicad import Allegro? So there's an open merge request that's on GitLab, so it's called a merge request. And I actually built the kicad nightly with it and did manage to import it. It's on my laptop, and I'm not sure I can share it, so I didn't add it to GitHub. Let's see if bench works. That's other bench. Overhead. Oh, look at that. Awesome. Okay, so it's going to have a shadow. There's a light, and I don't know how to turn it on. I think there's a light. And there's a little bit of a shadow. Sorry about that. Okay, so let me flip it too. So it's looking the way that I'm looking. So here is the main chip, which is insane. It's insane that it's that small. So what we're interested in is basically there are a few capacitors here, C69 and C70. And then this is the flash. And these are the two crystals. Crystal here and here. So there's going to be crystals there for support circuitry. I don't know what this box is telling us, but maybe that I don't know. Look at those. Those are tiny, tiny parts next to it as well. Like, those don't look... 192 pins on that footprint. It's insane. Yeah, BGA is insane. We can see it's like the DVL. But, like, yeah, then if you can get it fitting on a feather, like, that would be sweet. And that's the thing that I found whenever I do PCB stuff, is that I do these PCBs, I order them, and they come back and they're tiny, right? Like, and if you like have it full screen on a giant monitor, looks like 042 or 402 for the most part. Okay, let's look at the back. So here's where the chip is. I'm just gonna flip it over, and we'll take a look at the back of it. So you actually probably have a better view than I do because I have it on the, I can make my screen bigger, but let's just find, what schematic is this? This is revision A2, so I think the schematic I'm looking at is A3. Hopefully they didn't rename it. And is that blurry? Yes, that's blurry. Let me hit the... That's a little better. I messed up the lighting. That's a little bit better. Can we find any of the C30s? There's like a lot of resistors. Here's the actual, oh, and I'm overlaying it. You can't see where I'm pointing to, but it looks like the chip is actually up here, and then there's a lot of stuff. This must be where all the power circuitry is. So this is the chip, but then there's a ton of stuff below it as well. And they do look pretty big here. And I see a C35. But it's mostly like C9, 11. I see two C12s. Is that really what it is? I guess 06, 03, and 04, 02. Yeah, sorry, I don't have a great... It looked bigger in kicad. Yeah, exactly. Exactly. Okay, so there's 12. 12, 11, 9, 8, 10. What signals / bus are length specific? So this actually does have, well, the ones we're seeing, this board actually has, well, I think this might be the flash here, but then there's a bunch up here, and I think there's a RAM chip probably above these capacitors here. Let's just flip it over. If we look at here, actually, yeah, so I think this is hyperRAM. You can see there's more traces on this side as well. And then this is power stuff, and then this is flash. Although it might actually be, you know what? This might actually be, I think that this is actually the flash, and then there's also like NAND flash or something on there. Or HyperFlash or something. They might have two options. We could actually look. So this is marked what, U19? Is that what it says? There's U19 and U33. And so let me desktop with overhead. So if we search around here, main power. It's funny that it's funny to me that they have Arduino headers, like Metro, Arduino standard headers. So you backlight because there's an LCD connection. So they really they wanted to pop out absolutely everything. CAN bus. This is main board. Mic, SPDIF, so audio, Ethernet, ESD, SD card. Okay, so yeah, so here's U19. So it has both a HyperFlash, which is 8-bit wide, and then it also, and you can see that there's two options. They really try to do everything with these EVKs. And then the other option is the QSPI flash, and that's what we're used to using in CircuitPython. So that's what it's meant to be, or what we use. Dave, we're early. Yep. Glad you could make it, though. Yeah, usually I'm in like 2.5 hours, but I have a toddler with a doctor's appointment at 3 because of an ear thing. He's got an ear infection, and he had, I think it's the same ear, he had an ear infection, I don't know, months ago now, where it actually burst. The eardrum burst and like drained all the gunk out. So yeah, toddlerdom. Anyway, he has an appointment at 3, right in the middle of when I stream usually. So I was like, I'll just stream now. I can do my email later. So I kind of swapped my day. So I'm glad you could make it. That's the wavy lines there, and then there is actually, let's see on the schematic if we can find SDRam. So there is actually an SDRam chip on here as well. So a lot of the wavy lines are for that. And that is marked U20. So if we go back here, it looks like, oh yeah, the U20 is right here. I know it's a lot smaller because it's on the side, but yeah, the U20 is the other things. And that would be, I think it'd be really cool to support SDRAM in CircuitPython. That's one of the like, oh, like, you might think, oh, we've done everything. And you're like, wait, like, there's somebody that was working on the Daisy Seed board, which is an audio, aimed at audio board with an ST chip on it, but it's got 65 megabytes of RAM. And the way that they do that is it has a mega RAM internal and then 64 megs external, which is neat. And SDRam should run a lot quicker than like PSRAM. Whew. Although, I showed it on Show and Tell. I have a hacked up Metro M7 where I plopped a PSRAM on top of the flash chip and can actually can use that too. So that hopefully we'll do that at some point soon too. Okay, so it really does look like a lot of the decoupling stuff is actually off-boarded, is not close under it. So maybe what we do is we do a little more on this. So here they do say, like, place these next to these balls. So maybe what we do is we try to take this as minimal as possible, right? Except it says and so on. It's like, do I place all 5? I don't know. It probably will work, right? I don't know. These are meant to be kind of conservative. And then M1, which I think I did. Okay, so we were looking to see if they were using 0201s, and we decided that they weren't, right? Is that what we decided? It's just so, it looks so big on the screen. This does not need to be there. We can run that signal. We could run that signal out and back if we really wanted to. And in fact, there should be, where's this capacitor? It's way over there. This capacitor is going to want to be close to. And we might want to move it. We probably do. Maybe what we do is we actually move this. It's just a signal. It's not a power decoupling cap. So I'm thinking like move this way over here. And then we can run the signal like right underneath. Something like this. We don't need it close. Mom is usually just a recommended. Going smaller is always okay. Larger I would avoid for decoupling. Size has bigger impact than actual capacitance. I can't imagine Lamore would be particularly happy with 0201s. Even though I think even though she'll probably still have JLC make it. This is a NeoPixel. Okay, so I think I got most of these in here. If we're going to do via InPad, we've got to probably align. Yeah, well, I kind of don't think Adafruit HQ will assemble this because I don't think they've done any BGA. Like these 233s make me feel like we're gonna want decoupling there too. So why isn't it like that? Yeah. I think 0402 is probably fine, but it might be a bit much to do. I'm now watching a guy do schematic capture on YouTube in my free time. So this is a deep dive. Welcome. I don't hardware hack. I work for Adafruit. I usually do software, so don't do that. But my defense of all of this is that deep dives are really nice if you want to see absolutely every step that somebody does, right? If you have something that's a 5-minute video and they've like really done like their duty to get it down to all the steps, they might like kind of gloss over exactly how something is done. So that's why I do find it when I'm doing very technical things like this, it is actually really nice to just watch somebody do it. So that's my assertion. I don't really want to put this 0603 underneath if I can help it. I'm the first guy in 26 years to understand your username. Great. I'm glad I got it right. You're not. I don't always. Welcome. So deep dives are usually at 2 p.m. Pacific. I'm based in Seattle, but I have a doctor's appointment for my 2-year-old today. So we're doing it a little. Okay. Do it a little bit early today. I don't know. Maybe I just make something up. Although I definitely am going to want... How did I get away with just like 5 underneath it? It's not just 5, that's why. I definitely see 2 sizes. And they look real small to me. I think there are some 0201s in there. For sure. Like, this is not a... I don't know. I mean, if JLC can do it, right? Like, but in here, like, those small ones look real small. Like, I'm looking at the vias coming down, and they look like they're bridging the vias, which would make it way simpler. Don't know. If you struggle to see it by the naked eye, it's 0201. Well, maybe not then. I mean, I have quite good eyes for being almost 38. But I'm looking at the via pattern and comparing the size of it. Like, those are 0402s. See, I think this is a 0603. I think it's 0201s and 0402s. I'm over-optimizing, though. I was looking to see if somebody had already done this. That was the other way. It was like, if anybody has it public. 0201 fits perfectly between 2 0.5 millimeter FPCs. Yeah. I'm starting to get hungry, so I don't know. I think my brain is still figuring out how I wanna do this. You have a dev kit for that chip too. Yeah, you have the one that I'm looking at, some version of it. All right, well, hang out. Anybody have any questions? Oh, if you want to join the Discord, which is the chat above me, it is the URL adafru.it/discord. That will get you into the Discords. And the nice thing about that is that it's a chat that lasts all the time, rather than just goes away with the stream. So I recommend you join the Discord. They're all week. Okay, so it's a different version of the i.MX RT. All right, well, yeah, I was looking at the Teensy too, and like SparkFun has a micromod for it as well, which I think is actually an interesting. I think they call it a Teensy. I really don't like that they did that. Oh yeah, they moved it on me. Processor boards. I think this is one interesting argument for something like this, where they also use the VL. Where you pay for like a really like 6-layer board, but then you put it on a cheap board. Like that's actually a really interesting case for this. It's interesting that they call it Teensy branded. Let's see, there's not that many chips there, and then, oh yeah, look at that. I can't get it any bigger. But if we look here, that's really interesting. Oh, you can't see what I'm seeing, sorry. I figured it out. So this is the micromod. And it does kind of look like they did via and pad, but they're stretching further along. Like, there are slightly different sizes here and here. It's like quite compact, actually. Like, there's a quarter if you're in the US. So there's the chip. They have 2 extra capacitors here and a big bulk one. This is your flash. Or no, you know what? This is probably, since it's labeled program, this might be, this is why it's called Teensy, is that it's probably got a Teensy bootloader on it. Normal VIA is not plugged. And it is interesting how they, like, this must be the ground right in the middle. Yeah, pretty wild. You know, this one might be open source. I wonder why it's backordered. SparkFun usually does open source stuff. Teensy is not open source. It's a collaboration documents. Oh, they have Eagle files. So they did open source it. Maybe. Oh, it's Creative Commons Attribution Share Alike. DCDC. DCDCN. There's only one capacitor there. Huh. Yeah, I mean, Paul, who does, well, Nathan knows his stuff too, the SparkFun guy, but Paul, who does Teensy, is like, he's been doing this chip a long, long time. So he's got a lot of knowledge about how to do all this layout stuff. All right, I'm getting hungry and I gotta figure stuff out. So let's wrap up for the day. Sorry, I advertised it as one. Well, I'm early, and then I had the title that wasn't actually what I worked on. But I am kind of wanting to work on that other stuff, so I might pick that up later today on my own time, because I probably won't be back to my desk for the rest of the week. This has been a deep dive. I hope it was enjoyable watching me fumble around with hardware. If you have tips or you want to help me out with it, let me know. I can publish. I think I can publish it. I just, for some reason, didn't want to. Anyway, usually I do software. Next week, I'm so scattered. Next week will be FoamyGuy, because I will be out on Friday. It's usually 2 p.m. Pacific here on the Adafruit streams. If you want to support me, you can go to adafruit.com, purchase hardware there. They pay me quite well to do rambling hardware streams and all sorts of software streams as well, and software in general. So thanks to them for supporting me. Support adafruit.com. Thanks to everybody in the chat. I know it was late notice that I had to rearrange, but I'm glad I got to deep dive anyway. And I think that's about it. Hug in advance, or thank you in advance to DCD, who usually takes time codes. And I put those in the YouTube description so you can kind of skip through everything that we talk about. And with that, oh, Todd, sorry. Yeah, good luck with the doc appointment. It should be fine. He's actually like feeling fine as far as we can tell, but they were like, yeah, we should just take a look and make sure it's okay. Should be fine. Anyway, I'm glad I got a European-friendly time, and glad to see you all. Have a great weekend. I will be on the Discords next week, although I'll be off and on as well because new daycare is in addition to things. And then July should be more stable. Like after the 4th of July, I should be around more regularly. All right, with that, we'll do a window scene and then we'll get out of here. Thank you all for hanging out. It's got a little cloudier since then. Have a great weekend, and let me know if this is interesting to you or not, if a 1060 Adafruit board is interesting or not. So thanks a lot. Have a great weekend.